So it seems that Mr. Oakley needs some more clarification on the second law of thermodynamics, so let's get to it. First, let me just say that I do now understand why you don't quite grasp the second law of thermodynamics, Nathan. It's because, like most, if not all, flat earthers, you don't research things to the extent that they require. You research, you find something that you believe fits your narrative, and then you stop there. This was evidenced in your response to my video, just looking at how the very dated experiment that you showed there. Obviously, if you found, or if you'd carried on researching, we'd see something more current, I guarantee it. But it did help me realise what I'd sort of missed, and how to try and better help your understanding. So first, let's sort of try to wrap our heads around the whole entropy thing. Now, entropy is quite often described as a measure of like disorder or chaos within a given system, but that's not the whole story. It's simplest if you look at it like when a system has an increase in wasted energy, it has an increase in entropy, and it's naturally going to have an increase in disorder as well. But again, I didn't really explain everything clearly, so we're going to try to clear that up right now. So we'll take a look at how entropy works with gas molecules in a vacuum or a closed container. Now, if we have some gas molecules in a closed container with no way of the gas escaping, that would be an isolated system. An isolated system allows no transfer of matter or energy at all. In this case, entropy would deal with the possible amounts of microstates that the gas can take within the container, in essence measuring the disorder of this isolated system. As we cannot control, we can't control how the gas moves as they bounce around, they're hitting the walls and each other, they're wasting energy, unless they're in a ideal state, in which case energy will be conserved, temperature won't change, and entropy will remain constant. However, in our example, gas will always fill the container, but only when the container is an isolated system. So it should also be noted here that gas is never truly ideal, but at high temperatures and low pressures, gas molecules will behave as close to ideal as possible. So the reason I'd stated that you, Nathan, and other flat earthers are using the second law of thermodynamics incorrectly is, well, one, because Earth is not an isolated system. It is essentially a closed system. You've got, obviously, I've explained isolated systems. You've got open systems where matter and energy can come and go freely, or is transferred, like all the time freely. Closed systems where matter cannot, come and go, but energy still can. So, with the exception of like when we send astronauts up to space, or when like a meteor comes through the atmosphere and crashes into the planet, matter is not normally coming and going from the Earth's system. So in such a way, we call it closed. You can, to make it easier, you can look at it as an open system in energy only. I should also point out as well that the definitions that I'm using are in regards to thermodynamics. It's very important to know that, depending on where your arguments are coming from, and what sort of area of science, or anything really, words can have very different meanings. Go back to the whole theory thing, where in regular parlance, theory is just an idea, but in science, theory is basically the highest of the high, really, because it's taking something to the topmost point of our understanding at that time. Obviously, as technology continues to just get better and better, things can change. But where it sort of affects what we're looking at here is, when you look at something like like a closed system in classical mechanics, that is the equivalent of an isolated system in thermodynamics. You know, so it's very important to understand this. So now let's get to the meat of the issue. We know that Earth is not an isolated system. We also know that gravity exists and affects the molecules in the air, causing a pressure gradient. Earth's atmospheric pressure gradually decreases as it gets further away from Earth's surface, eventually reaching 1 × 10 to the -17 torr. When we have a pressure gradient, it means that it's set up so basically the top of, you know, one level is going to become equal. It's going to end up equal with the bottom of the next level. This is how the gradient ends up forming. Just like with the, you know, where the atmosphere meets the ocean, the very top of sea level is the same pressure as the bottom of the air on top of it. So, you know, this is why Earth's atmosphere doesn't get sucked out into the vacuum of space, because, you know, gravity, as well as the movement of molecules and heat from the planet, causes atmospheric pressure to be like highest at Earth's surface, where it's warmest and gravity has a stronger pull on it. And then, you know, it gets weaker and weaker in each gradual layer until it finally, you know, way out there past the moon and everything, it finally hits that 1 × 10 to the -17 torr. But at that point where we're hitting that part of space, our atmosphere has spread that thin that it balances out. That is why there is no, you know, getting sucked out into it. Lastly, you know, just to point out one more thing, you know, where you got it wrong, Nathan. You constantly say that the second law of thermodynamics states that gas will always fill available space. That's not what the second law of thermodynamics is. That's not what that's not what entropy is, or what entropy states. You know, however, like a gas filling all the available space of a closed container will cause entropy to increase, but you know, we can also see an increase in entropy from solids and liquids. You know, you've looked at that experiment and you've heard him use the word entropy, and then, I don't know, you've probably researched entropy and found out about the second law of thermodynamics, and you've just completely misunderstood it. So yeah, Nathan, I guess, you know, you might want to understand what you're talking about before you try, you know, to debunk it or you know, say it violates it. Earth's not an isolated system. There is no firmament. Space is real. Gravity does exist, and you know, you still don't understand what the second law of thermodynamics is or how it applies to Earth. So yeah, #GlobeSlapped. So guys, if you enjoyed today's video, please do leave a like and a comment. If you haven't subscribed, please do, and hit the notification bell so you can stay up to date with my latest content. If you'd like to support the channel financially and help me put out more content, and you know, and just grow the channel, there are links to Patreon and PayPal in the description. But honestly, you know, just you guys viewing it is more than enough. And then lastly, in the description, there's links to my Discord server and other social media. Just, yeah, that's it. As always, I've been LimeyPlay. You guys are awesome. Take care of yourselves and each other. Yeah, that's it. As always, I've been LimeyPlay. You guys have been awesome. Take care of each other and stay safe.